Alright, in this video what I want to do is I want to create the ability for the master server to tell a region server, or to select a region server, and have it start a game simulation. And then when that game simulation is started, have the region server notify back to the master server, then have the master server notify back to the client. Now the cool thing about all of this is we already have most of it in place. In our game lobby, our begin game method, we are returning the deferred from begin game. And that means that all the notifications are already happening right here in this code. Not very much code, but a lot's going on. So now we just have to implement the game server's begin game method. So what it needs to do is it needs to select a game instance system. And then it needs to tell it to begin a game. So how would we go about selecting a system? So I'm thinking about this, and I'm thinking that this is going to be kind of interesting. Returns an enumerator. I wonder... Because we're using a concurrent dictionary, I decided to play around with that. So let's go ahead and find out if there's a way to loop over a concurrent dictionary in a thread-safe manner. And taking a quick peek at the documentation, it seems that the enumerator returned from the dictionary is safe to use concurrently with reads and writes to the dictionary. However, it does not represent a moment-in-time snapshot of the dictionary. The contents exposed through the enumerator may contain modifications made to the dictionary after get enumerator was called. So, I think it's safe to say we can do a for each loop. So in this case, what I'm going to do is I'm actually just going to select the first server. We'll put in logic for selecting servers later. So I'm going to say var server equals servers.first. And of course, since the first link method will be using the getEnumerator method under the hood, this will be type safe, and it'll just return the first server. So now we need to tell the server to go ahead and start. So the server, what I can do is I can do server.value. Let's go ahead and just do first.value. Server dot, and then we have direct access to the proxy. And the proxy currently doesn't have anything in it. We don't have a method for telling the server to begin a game. So let's jump into our BuzzMMO server components game instance. And let's add a method on our game instance's region for beginning a game. So I'm going to do deferred of game instance, which I believe has the server, the level name, and the ID. It does. So deferred game instance begin game, and it'll take in game parameters. Then, now inside of my game region server queue, I can simply return server proxy begin game, passing in our parameters. And all of our asynchronous infrastructure will handle pretty much everything at this point. So that is awesome. I do think, though, we will have to address the possibility of a server disconnecting while a request is in flight. So I'm thinking that we will have to add some code into our systems implementation that checks to see for all the in-flight requests, if there are any in-flight requests when we get a disconnect signal, to go ahead and nuke all of them and set an error. Let's actually go do that now, because if it takes, like, if we do the begin game and we start that in-flight request and then the server disconnects, it'll never get notified that that in-flight request got resolved, which will result in the clients just kind of sitting there waiting for the game to start. So that's obviously not what we want. So let's go ahead and fix that. That's going to be in our... That's going to be... So we have client systems here. It's not going to be in our client systems. It's going to be in our MMO peer base. If operation code is send system response, the method invoke ID is our operation request. System invoke ID, then we do callbacks, get callback method invoke ID, and then we invoke the callback with the operation code in the parameters. Oh, this is going to be, this is actually going to be a bit of a pain to implement. because it's at the peer level where if we get a disconnect, we need to do client context on disconnect. And whoops, I hit F11. I hate it when I hit F11. I believe that's going to start a debugger. And because it's Visual Studio, it's going to take forever to start a debugger, so stop that. Okay, so on disconnect, systems dispose, client scope dispose, and disconnected invoke. So we have that. We have our... Well, wait a sec. So we have invoke method on system, which is that protected void, which comes from on operation request, invoke method on system. And that's going to come from our systems operation writer, isn't it? So it's mostly on the client side, though, but we did have in our BuzzMMO server region, we did have this thing. I somehow completely managed to forget where... Okay, let's just trace this in our heads real fast. So in the region server queue, if it says server proxy begin game, what's going to happen is that's going to invoke our BuzzMMO server client systems proxy interceptor, this one that takes in a deferred, and this guy is going to invoke the send event with response with this response deferred.load response serializer. So the problem is yeah, this is not going to be trivial. This is going to be another thing that I'm going to file in the back of my head for a refactoring. The problem is that our client systems send operation, transport send operation with response has really no way to, it registers this callback. But what I need to do is when this MMO peer base disconnects, I need to dispose all of the callbacks, but I can't just invoke the callbacks without filling in parameters saying that that particular thing failed because of a transport error. Well, I suppose I could. Let's think about this. I suppose I could, on my callback, have an operation code that specifically says there was an error. Yeah, I don't want to think about this. This is just going to be filed in the back of my head for a refactoring of this particular system. So let's go ahead and not worry about region servers disconnecting in the middle of beginning the game. So we have server proxy begin game. So now we can implement the other side of that, which is going to be under BuzzMMO server region systems master game instance system. And we, of course, have to implement the missing member, which is begin game. So now on this server, we just need to return a deferred when the game begins. And we can test this real fast. I can just return a deferred.success new game instance, passing in an ID of just arbitrary garbage, and then passing back in our parameters. Why doesn't it like that? Oh, Photon server connection. New Photon server connection. Actually, I'll literally pass in our context .config here. Game server .udp connection. So let's go ahead and test this first to make sure that the communication is properly working between the master and the region server. Come back here, hit play, wait for Entity Framework to hurry up and do its thing. Log in, create, start. Game started on 127.0.0.1.5056. Sweet. So, now that we have that information, we need a way to connect to the region server. So jumping back into BuzzMMO, I'm not going to worry about on the begin game. I'm not worrying about creating the simulation yet, because that's going to be the big thing that we're going to need to do on the server. But it's okay. We don't have to worry about it yet. Now the big question is the server or the client needs to connect to the master or to the game server. And I think what I'm going to do here is on scenes, I'm going to create a new scene. Or how about create a new folder here and call this levels. And create a new scene called level 1. So create scene level 1, and then open up level 1, and this will just be a basic, I don't know, so we have a main camera here, and then we can put in a I don't know, 3D object cube, and where are you, Mr. Cube? There you are. And so move the main camera so that it sees the cube. Whoops, why did I put the cube inside the main camera? That was a silly thing to do. So now we should be able to know when we switched scenes, because we'll see that awesome little box there. And now I'm going to go back to loader. So what we need to do here is on the client, on game started, we need to completely disconnect from the master server. Or optionally disconnect from the master server. It doesn't matter. But in this case, I am going to only have the one connection open at a time here. So we'll disconnect from the master server, then we'll connect to the region server. And we do that by switching over to our context. So we have our master server iConnection manager. We're going to need to create another iConnection manager for our region server. So I'm going to go into code and create a new folder called game server. And we're going to create a class here called game server. And he's going to implement iConnection manager. And what we're going to do here is to switch over to the game server. Remember, on our game context, we have this method called, we have these connection manager factories. So we have the connect to master server, but we also need a method to connect to the game server. So I'm going to jump back into master server systems game lobby system. And on game started, we're simply going to do context dot connect to game, passing in our game instance and our game parameters. All right. And then I'm going to go ahead and say create method game context connect to game. We have our game instance and our game parameters. And I'm going to go ahead and move this up to our section for our manager factories, and I will have this return a deferred of game server.game-server. And then for this, what we're going to do is, let's see, we're going to do the same thing we did up here. I'm going to follow the same pattern. Func deferred of game server.game-server connect equals this, and then we're going to return our current connection manager does not equal null. If it doesn't equal null, then we'll return connection manager dot destroy, then connect. Otherwise, we're just going to return connect. And then to actually connect to the server, we need to instantiate our game server. So I'm going to say var manager equals new game server dot game server, passing in our context, passing in our game instance, and passing in our parameters. And then I'm going to say connection manager equals manager. And I'm going to say return manager dot initialize. Then I'm going to do deferred dot success manager. So there looks like there's a big opportunity to write a generic form of this connecting to a connection manager, but I'm just going to keep it pretty much as it is right here. So we now have to write our game server.game-server. Before we do that, though, go back to the game lobby system. Remember to have context.connect to game right here on game started. In fact, we could do something like context, prefabs, instantiate, alert dialog, set title, joining game, ... set can dismiss to false. And then I thought I had a wait for. So then I'm going to say wait for, and then I'm going to pass in context, connect to game, game parameters. So wait for, again, will show the error if there is an error at all, and so on. So I think it also sets can dismiss to false, doesn't it? Yeah, it already does that, so I don't need to do that. It's just set title, whoops, set title joining game, and then connect to game. So connect to game is going to instantiate a game server, and the game server is going to need a constructor. So it's going to be very similar to the master server. So our master server takes in a game context, then it has its update, its initialize, and its destroy. I'm going to move this off to the side so I can see this and refer to it. Our game server, however, is going to take in a game context, a game instance, and a game parameters. So we're going to take in a game context, game instance, and game parameters, and we'll alias these all out into fields. And then what we're going to do in here, in the main thing here, we are going to create a transport. So we need to have a private read-only transport. So private read-only iClient transport. And we're also going to need a systems module. So public systems module systems. If you recall, the systems module contains all of the code necessary in order to deal with a systems implementation using our bidirectional framework. And then I'm going to go ahead and say underscore transport equals context.create transport. For the Photon server connection, we're going to pass in instance.server. And then we're going to say systems equals new systems module, passing in our game context and our transport. For update, we're simply going to do transport.update, or transport.service rather. Now for initialize, we're going to need to load in our scene. And what's interesting about what I'm going to do here is I think I'm going to make this a little interesting actually. I'm going to make another scene here. I'm going to go in scenes, I'm going to right click, create new scene. I'm going to call this UI. This is an idea that I have that I wonder if it's going to work. Also, make sure that you go ahead and add, go to your build settings and add or open scenes. Oh, come on. Okay, jump into UI, go to build settings, add open scenes, then go to levels, level 1, build settings, add open scenes. Make sure you add that. And then in UI, what we're going to do is we're going to create a canvas. That's going to be our user interface. So we'll create a UI canvas. We won't need an event system because that'll already be present. We won't want a main camera or a directional light. We just want a canvas. And then in the canvas, I'm just going to go UI and I'm going to create a button and I'm dock it, I don't know, down at the bottom. I don't know. It doesn't matter. We'll write our game UI later. So what I'm going to do is I'm going to load the UI scene in, and then I'm going to additively load in level 1. So the UI scene will get overlaid onto level 1. So let's come back into our client code. And on initialize, what we're going to do is we're going to say return context load scene UI. How about, let's rename that to game UI. I'm going to rename that to game UI. Come back here. And then we're going to pass in a load scene mode dot additive. Then I'm going to say then context load scene, and we're going to want to load our level that we want to start. So that's going to be underscore instance dot level name. Then after we do that, we're going to want to do transport dot connect to connect to the server, finally perform the actual connection. And then on success, we're going to want to do transport, send operation, operation code, init context, passing in our new dictionary of byte and object. So we want to init our game context. And then we'll pass in a byte of operation. What am I doing wrong? I don't know what's happening. I don't know what's going on. Operation parameter dot context type, and that's going to be context type of player. And we're also going to pass in another operation parameter. Well, we'll do that later. Well, because we're also going to pass in a operation parameter for the current game and our, well, not necessarily, we might not have to do that actually. We could do that through our systems API and not have to worry about complicating anything else. I think we'll go with that. So we just need to make sure we initialize our context. Okay, so that'll all work. That should all work. And then for destroy, we'll simply return transport disconnect. Now what I'm going to do, I do kind of want to make a change here to our game context. Because once we do connect, if we fail, I want to reconnect to the master server. So I'm going to say var def equals, and then I'm going to say def on fail, and on fail is going to say connect to master server. And then we'll return def. I have no idea if this is going to work. Let's jump over here to our Buzz MMO first and see what happens when a player joins. If we jump into peer, we have a player, init player context game, does nothing. It literally does nothing. But what we can do, I suppose, is put in a debug here. So do a private static read-only ilog log equals log manager get logger type of peer. I really need to redo that snippet thingy. I'm going to say log info player from this dot. What is that? Okay, remote IP. Connected. All right. So hit F6. Now, in theory, what should happen when we start a game is we should... what should happen when we start a game is we should switch to a different scene. So remember, when we get the notification... Let's just walk through this one more time. When we get the notification that on-game started, we instantiate alert dialog, and then we wait for context connect to game. Connect to game simply instantiates a new game server manager, and then initializes it. And to initialize the server manager, it loads the game UI. Actually, no, this is backwards. The game UI I don't want to load additive. I want to load... It's a good thing I walked through this. I want to load in the level name as additive. And we should make sure over here on our region server, in our systems master game instance system, that this is actually level 1, because we are referring to that as an actual scene name to load. Okay. So, no idea what's going to happen, but let's do some science. Let's open up our loader. Let's hit play. Log in as admin, create lobby, start game. Well, starting game. And we actually did player from 12700 connected. So we did actually properly hand off the communication. Let's go ahead and make sure that the player was also removed from the lobby and the lobby itself was destroyed. So I'm going to launch another client here by hitting Control B. And wait 27 years. Come on, you can do it. So then we'll launch this, and we'll go ahead and log in as admin, and then over here we'll log in as Nelson, and then we'll create a lobby as admin, then we'll hit start. And admin did go away, and the lobby did go away. And we can do the same thing here. We can do start. Okay, sweet. So the only thing that's wrong here is this starting game dialog box doesn't go away for some reason. That's cool. They changed the inspector a little bit. Huh. So we have our game UI, which is technically the scene we're in, and then we have our level 1, but then we're connected. So let's make sure that thingy goes away, which I'm not sure why it's not. Let's jump back into game lobby system, joining game. Or wait a sec, what did it say? Joining game or starting game? I already forget. Blah, 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 start. It says starting game. So the starting game message is not going away. So let's go ahead and trace that real fast. In our master server, in our lobby window, we should have a method here for begin game, which waits for proxy begin game. And for some reason that isn't being closed. So it's not receiving a deferred notification that the game started. Ooh, I know why. It's because our game started event in our game lobby system on game started, that happens before the begin game does. And then when this message comes in, we disconnect from the master server and never receive a notification that the begin game started. So that's another thing that we're going to have to address during the refactoring. I think what I'm going to do instead... is, first of all, I'm going to simulate it taking a little bit of time to begin a game. So this begin game... do we have a fiber? Oh, no, we don't have a fiber, do we? Blah, blah. We need a way to wait. Oh, let's just be lazy. We're programmers, we can be lazy. Var thread equals new thread with a thread start of thread.sleep for, how about 2 seconds? And then def set result to true null followed by our thing, but this deferred needs to be a deferred of game instance. And then we will return def. And then we'll do thread start. Okay, so we're going to simulate 2 seconds to start the game. What I'm going to do here is I'm going to go into the client, and instead of saying starting game, I'm going to say, I'm simply going to say proxy begin game, and I'm not going to show a dialog. But what I will do is when the lobby is updated on update lobby, and remember, update lobby is invoked by the game lobby system directly. What I will do is I'll say if details change contains flag passing in lobby details field status. Then what we want to do is say if details status equals lobby status dot active, then we will activate our buttons. Or how about just hide our admin toolbar? Yeah, I'm just going to hide our admin toolbar. I'll go hero dropdown enabled equals false. Team dropdown enabled equals false. What am I doing? I'll just say equals team dropdown enabled equals false. And then I'll say admin toolbar set active false. And then I'll do an else, and the else will do the opposite. Actually, what I'm going to do is I'm going to make this easier. Bar is active equals lobby status is active. And then I'm just going to do that. So when we get the notification that the status of the lobby has changed, we're going to disable the controls to indicate that we're starting the game. And we can even show like maybe a message or something. I don't know. It doesn't matter really. So I'm going to come back into Unity and see if that was effective. So I'll go ahead and play admin creates, and unfortunately we got a lobby status is active equals lobby status is active. So what is debug log details status? Why is that being a pain? I don't know. Great. All right, we have a status of 0. Is 0 active? I don't think 0 is active. Active is 1. Do we never set the active in our game lobby? Do we never set the status in our game lobby to active ever? No, we don't. Okay, so what I'm going to do is we're going to initialize our underscore status to equal lobby status active. There we go. So that made us able to catch a little bug there, which is fine. And with that, now we should be able to come back here, hit play, go to, oh, we restarted the master server, so it has to reconnect to the database. Go to admin and go to create and hit start. And we wait 2 seconds when it's inactive, and then we start the game. So yeah. I think that's going to wrap up this video. We still have more to do with the connections, dealing with jumping back into the master server and all that fun stuff. But we now have the ability to connect to a master server, log into a master server, create a lobby, and start a game and have the master server pick a region server and all that fun stuff. So I think we're pretty good to go. And we'll see what happens in the next video. And we'll see you guys then.